Dear students, welcome to the knowledge series. Here, example related to the Dijkstra algorithms to find the shortest path is shown. Let's see how to solve it. I would advise that you should watch my previous video series on Dijkstra's algorithms, and several other examples are also been shown. So, as per the Dijkstra's algorithm to find the shortest path, in the given figure, we are seeing that there are 7 nodes are there, or 7 vertices are there, and every vertices are having a loops are also exist. That means in certain vertices like A and E, D and G, you are finding a loop. So how this particular problem we can solve? So we follow the basic methods, that is we go with the steps. So let us write the step 1. Step 1. In the step 1, what we will do is that we will assign weights of all direct and indirect vertices. So let us see how to assign the direct and indirect vertices. So we will start with from A. So if this is our starting point, let me put this one as a start. So we will assign the vertices of A as 0 weight, and then the corresponding neighboring nodes B is 2, and with respect to neighboring node C it is 7, then corresponding to E it is going to be 12, because 0 plus link cost 12 is equal to 12. Then we will see that all other nodes, all other vertices, that is A to D, it is indirect, so that's why it is infinite. A to F, it is indirect, it is infinite. A to G, it is indirect, so it is infinite. Now we go to the next step 2. In the step 2, we will try to find the shortest path of respective vertices. So we will see when we consider A and its neighboring node B, C and E, among these 3 nodes we find 2 is the smallest vertices. So shortest path from vertex B. So we see that from B only one link is emerging out, so we consider BD. So BD means weight of B is 2 plus link cost between B and D is 2, that is 4, and 4 is less than infinity, that is the assigned weight of D. So it is a relaxed conditions. So relaxation condition satisfied. So now we modify the weight. So we will modify this weight of D from infinity to 4. Now we go to the next. What is next to it among this one? We find C. So we find and among this entire weight, this is 2, this become 4, 7, 12, infinity. So we find D as the smallest weight. So this is 1. So we go with number 2. So shortest path from vertex D. So we consider D, from D one link is emerging, so D to F. So what is D to F? D to F is D is having 4 plus 2, that is equal to 6, which is less than infinity. So it's a relaxed conditions. So we modify this one from infinity, it is modified to 6. Now we go to the next, which is our next. By viewing the figure, we will see that we find the A, B and D is over. So C, E, G, F, among this one we find F is the shortest path. So our shortest path from vertex F. So from F only one link is emerging out, that is F to G. So what is F? It is 6 plus 2, that is 8. Again it is less than infinity, it is a relaxation condition satisfy, so it has to modify. So from infinity we modify this one to 8. Now what is remaining? F is over. Now we are having the next condition is what? G, C and E. So G, C and E is why is that we find C is smaller as compared to the other two. So we go with the shortest path from vertex, which one? C. So we write C to E, one link is getting out. So C to E, C to E, C to C, what is that one? C is having a weight, that is 7 and plus 2, that is 9, and 9 is less than 12. 9 is less than 12. So automatically this is a relaxed conditions. So we modify this 12 by 9. Now from C there is one more link is emerging out to D. So CD. So what is this one? C is 7 plus of minus 1. So that is 6. And 6 is greater than 4. So no change. Next we go with next condition is what? C is over. So now our remaining is what? G is there and E is there. G and E. So among G and E, which is G is small. So next is shortest path from vertex G. So we write it as G to D. If you write G to D, that is you are having G is how the G to D. So you are having a weight of C is how much we got it as we completed C. Now we are having a two vertices G and E. So G and E. Yeah. Here G to D, when we consider its weight is 8 and D is here it was the link was missing, so it is 1. So plus 1, that is 9, which is greater than 4. So no change. Now what is remaining? Now the remaining link is E. So shortest path from vertex E. So we will write is only from E there are two paths coming, E to G. What is E to G? E to G is nothing but you can write it as weight of E, that is 9 plus of minus 7. So 9 plus or minus 7 is 2, which is greater than 8, which is less than 8. So automatically this is going for a relaxed conditions. So this will be modified and it will turn to 2. And what is remaining? One more path is between E and E, A. So this one means E is 9 plus of what is up to between E and A link minus 4. So that is 5. 5 is greater than 0. So no change. So this completes the every movement of the computed path from the various links. So when you see the path up to G, it follows the path like A, B, D, F, G. So this is the path it has followed. And if you see the computed path to D, so it follows A, B, D. And if you look for the shortest path to F, so A, B, D and F. So that's how we can see the shortest path. And the shortest path to D, that when we try to see, automatically we will find this is the shortest path. So these are the path. So A to B 2, A to C is 7, A to D is 4, then A to E is 9, A to F it is 6, A to G it is 2. So this completes the solutions related to the shortest path for the given figure using Dijkstra's algorithms. Thank you.